we talk today, we're going to talk about similar transformations. I'm going to ask you this. How can you use properties of transformations to determine whether figures are similar? Our LT, trying to draw and describe similarity transformations for the plane. We're going to use properties of similarity transformations to determine whether polygons are similar. I need you to make sure you write down similarity transformations.
Puerto Ricans are required to pay most U.S. federal taxes. The major exception being most residents do not have to pay the federal personal income tax. Coach, I've got my lunch I brought today, which is chicken tzatziki and original green potatoes.
Man, I got a lunch or something. I appreciate it though. You keep that when you eat. Alright, if you don't have it, I'll come back to it later. Make sure you get this part written down. The transformation that produces, I tell you what, this is the part you need to write down. That right there. Okay, that's what you need to write down. The transformation that produces similar figures is called a similarity transformation. A similarity transformation is 1, a dilation, or 2, the composite of one or more dilations and one or more congruence transformations. Two figures are similar if and only if, there it is again, if and only if there is a similarity transformation that maps one figure to the other. Okay. There's some important things. That's pretty much today's lesson in one sentence, right? We got to explore that one a little bit, obviously. Similarity transformation is a dilation. Okay? So first off, all dilations are similarity transformations. Right? We'll take a quick true-false quiz on that in just a second. All dilations are similarity transformations. But as well, anytime I have a composite, what does composite mean? Composite. Tyler Tracy, what's composite mean? Not sure? How about you, Miss Bell? You know what composite means? What might composite mean? Here is a composite. Okay? Composite means a combination of several things going on at once. Okay? Let's use Coach's example. Okay? Here's Coach's example of his sandwich today. The sandwich is a composite, right? Together. Bunch of stuff put together, we wrap into something we call a sandwich, right? What was in your sandwich today?
We had turkey, we had bacon, we had cheese, we had raspberry and cream cheese sauce.
Okay. So all of those things together, we put on the bread, and we say, that's a sandwich. A sandwich is a composite, right? In our definition today, you'll see this. A composite is when I have a dilation and one or more transformations. So if I have a dilation and then a reflection, a dilation and then a translation, a dilation and then a rotation. See how it's a composite? It's adding a lot of different things together into a single transformation, right? All right, so true or false? A dilation in and of itself is a similarity transformation. How about you saying yes, sir?
Yes, sir.
Yes, sir.
Okay. False or true? A dilation And a reflection is a similarity transformation. This doesn't work for me. Give me true, false,
True.
false, true. Thank you. False or true?
True.
A rotation translation is a similarity transformation. False. Okay. Was there dilation in there? No, there wasn't a dilation. Okay. Right. Look at this example here. Apply dilation D to the polygon with the given vertices. Describe the dilation. I did this one in your warm-up, partially. Okay, if I say from the original coordinates of x, y, I want you to multiply each particular coordinate by 3. What scale factor am I using? 3. Yes, it says it down here, and I know it says it down here. I'm just seeing who can read. Okay? But secondly, I also want to see if y'all know what happens here. 3 times 1. What is it, Ethan? 3. I know there's not any negatives involved, so you won't get tripped up. 3 times 1 is what? Good. So 3 becomes A prime. There it is right there. Ethan, 3 times 3. 3 times 1. Good. So go to over here, 9, 3. 3 times 3 is 9. 3 times 2 is 6. 9, 6. Okay? Yes or no? This is a similarity transformation. Yes. It's a dilation. Remember, that first thing we talked about, a dilation is a similarity transformation in and of itself. What's up? Okay. All right. I do the same thing here. Tell me this. What is my scale factor here? Yeah, I said 3/4. Okay. Will Mr. Foster, feels like you're not paying attention, will 3/4 reduce or enlarge my original, my free image? It will reduce it. Very good. By 3/4. Even. If I got 3/4 and I multiply it by 8, what do I end up at? 3/4 times 8. 6. 3/4 times -8. Good. Very good. Oh, hot dog. All right, I want y'all to do this. Okay, you need to write this part down. I want you to apply a scale factor of 1/4 to the following coordinates. -8, 0. -8, -4. -4, -8. Those plus negatives. Okay? You're going to multiply each of those by 1/4. I want you to tell me what is D prime, E prime, and F prime. Take a couple minutes. I'll get that going. 1/4 is your scale factor. Expires. Did you wake up? Did you apply a scale factor of 1/4 to those vertices? Way past that. Way past it. Miss Bates, what?
What?
Yes, ma'am. Miss Bates, what is 1/4 times -8? Camry, what you get? It's -2. Wow, she gave me the whole answer. -2 and then 0. Miss Bates, what is 1/4 times -8? This is not a trick question.
-1.
Ethan, those are negative numbers. I'm so proud of you.
I feel like it's
-4, -8. Which
-1.
you're going to have a calculator available to you. You know?
Yeah,
tell you how to use it every time. We're in big trouble this year. All right? All right, here we go. Now I've got to determine whether the polygons of these vertices are similar. What row? Okay. Now I got to determine if they're similar. Remember, if they're similar, they will have done a similarity transformation. See? So we need what? We need a dilation in and of itself, or we need a dilation and then a translation, reflection, or rotation. Okay? I know, man. Okay? See what I can think on that. I mean, call on now. Let me ask. It's been a while. How far is it from A to B? How far? What's the distance from A to B? Line segment AB. It's not 6. What's the change in my Y here? Close. No. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, got me? 9. Josh, how far is it from A to C? Nope. It's not 10 or 11, so I'm not good at that as well. Try again. What you got? 9. Good deal. Okay. No. 9. All right. Josh, can you now conclude that C to D would be 9 and B to D would be 9, correct? All right. Good deal. Watch what I did here. AB, AC, CD, and D to B. All of which are 9. Joshua, let's look at J to H. How about J to H? How far is it? Good. J to K. I'll see what this pattern is. 3 and 3, right? So JH is 3. JK, not interested in this case. It's 3. C to D, K to L is 3. DB, LH is 3. Guys, are those sides proportional? Say yes. Do they have the same ratio here? Okay, I'll go to my fraction, man. Even. What's the simplified fraction 9 over 3? Good. 3. 3. 3. 3. Dear Ethan, let me ask you a question. Okay? If I started at this square, JKLH. Okay, if I started this square and I dilated this square to the larger figure, what scale factor did I use? Three. G. Ethan, good job. Okay, you're welcome. All right, 3. If I multiplied each of those coordinates by 3, I would get the outer coordinates. Okay? I'll come to my second fraction man, Mr. Foster. If I started at these outside coordinates, A, C, D, and B, and I reduced my figure through a dilation to JKLH, what scale factor did I use? What? What would happen if it was 3 over 1? It would get bigger or smaller? What? Nope. Nope. This would enlarge it. Okay? 3 over 1 is the same thing as a scale factor of 3, right? But there's a reason why I put 3/1. Take the what? Yeah, we call the flip the what? Reciprocal. If I took the reciprocal of 3/1, that would be 1/3. My scale factor is 1/3. 1/3 reduce or enlarge. It would reduce. It would reduce each of those points by 1/3 such that they would map themselves to that. Okay? A lot of math right there. Yes or no? That's a similarity transformation. Yes, it is. Dilation. Okay? Oh, it's so much fun, guys. Don't worry about that one. Okay? Then we get fun stuff. Fun stuff. Okay? Determine whether the polygons with the given vertices are similar. A, B, C, P, Q, R. All right. First thing you got to do is you got to map out or plot these particular points. 2, -1, A. So you get 3, -1, B, and 3, -4, that's C. Okay. P is at 3, 6. Q is at 3, 9. Okay. And R is at 12, 9. That's good enough for me. Okay. So P, Q, and R. Okay. Similar figures, similar polygons have proportional sides. Similar polygons have proportional sides. Okay? To figure out the side lengths here. Some of them are going to be easy. How far is it from A to B? Along the x-axis, it's 1. Okay? How far is it from B to C? Right. 3. Right? Along the y-axis, it's 3. Okay, but how far would it be from A to C? Oh, snap. Gee, Hobbs, what did you do to me? Well, here's what I just did. Guys, the distance between 2 points equals the square root of the change in x squared plus the change in y squared. Yes, you need to write this down. You need to have it in your heart. I might tattoo it on your leg somewhere, although I wouldn't let you cheat and use it during a quiz or test. Okay, that needs to be written down in your notes. Right? The distance between 2 points in a coordinate plane is the square root of the change in x squared plus the change in y squared. Really one of those things that looks really hard. It looks a lot harder than it actually is. We'll use A and C is the distance that I'm trying to get here. A to C. Okay? We'll call A x1. So that means that anytime I have this x1 over here, I'm going to put my A coordinates in there. That would be that. My A coordinates are at 2, -1. So I put the 2 here because it's the x. And I put the -1 here because it's the y. My C coordinates are we're calling it x2. Okay. All right. 3 minus 2 is 1. -4 minus -1. -4 plus 1. -3. Mr. Hobbs, what's -3 squared? -3 times -3 is 9. 1 times 1. That's 1, guys. Okay? Square root of 10, whatever that is the distance from A to C. All right? You get that far today, you're very, very pleased. What I would then do is this. I could then take these side lengths So QPR, find those distances and put them in a similarity ratio to determine if they're proportional or not. Okay? So, Q to P, let's see here, that changes 3. Q to R, that change is 9. P to R, I don't know, I'm gonna have to use my distance formula. Do the same thing. X2, let's make, let's see here. Let's make this X2. 12 minus 3 squared plus 9 minus 6 squared. Okay. Right? 12 minus 3 is 9. 9 squared plus 3 squared. Square root of all that. 81 plus 9. Square root of all that. Square root of 90. Square root of 90. Okay? Now I take the particular sides of the triangle. A to B. 1 over B to Q. 3. B to C. 3 over 9. A to C. Square root of 10 over square root of 90. I can put each of those into my calculator. I should get the same decimal. If I get the same decimal for each of them, I'm good. If it changes by 1 decimal place, I do not have proportionality. I can tell you right now, both of these were 1/3. I'm highly skeptical about the last one, but I'm mistaken. Put into your calculators. Have it in your calculators as a fraction. Square root of 10 over the square root of 90. Tell me what you get. Square root of 10 over the square root of 90. What'd you get? Okay. Did I get 1/3? If you didn't do it, that's inexcusable. Just ask you to do it. What the lesson is. So, do they have the same, or do they have proportional size? Are they? Did I end up with the same? Did I end up with the same ratios among the 3 sides? If I have the same ratios among the 3 sides, then I have proportional. Okay? Got me? So yes or no? Did I have proportion amongst the sides? Yes. If I have proportion amongst the sides, I've got similar figures. Okay? Yes. This is a similar transformation. Okay? It's about as hard of a question as I can ask. But that's good. All right. Question, guys. How would I get from this figure, from ABC to PQR? I would do what? I would dilate it, and then I would have to, I don't know, I'd dilate it, and then I could translate it. Yeah, I'd probably have to translate it. No, rotate it. Thank you, Coach. Appreciate that look. Probably rotate it 90 degrees. About counterclockwise.